Coming up on This Week in Radio Tech, Phil Larsen is our guest with QForce, part of QCommunications. He used to use drones to listen in on some really bad guys, but now he's listening in on FM and TV broadcasters and showing them what their exact coverage patterns are. Phil Larsen is coming up next on TWiRT.
This Week in Radio Tech is brought to you by Broadcasters General Store, with outstanding service, savings, and support. Online at bgs.cc. By Broadcast Bionics, with the Bionic Studio, including talk show control, social media, and visual radio. Broadcast Bionics brings exceptional audience engagement to radio and TV. By Angry Audio. Audio problems disappear when you get angry at angryaudio.com. And by Max Connect Wireless, prioritized high-speed internet service designed for transmitter sites and remote broadcasts.
Hey, welcome into This Week in Radio Tech, the show where we're talking about everything from the microphone, like this one, to the light bulb at the top of the tower. I don't have a light bulb at this tower. I'm at the Southern Command location of This Week in Radio Tech near Chattanooga, Tennessee. Hi, I'm Kirk Harnack. Delighted to be here, and a big thanks to my employer, the Telos Alliance. Telos Alliance, right? Yeah, right there. For giving me a couple hours to do this show on Thursdays. Much appreciated. All right, today we've got an amazing show for you. I'm so excited to have this guest on because this is one of my passions. I used to love flying big, regular airplanes. Well, little airplanes, 4-seater, 6-seater airplanes. And then that got too expensive for me. So I started flying UAVs, unmanned aerial vehicles. And, I do have a Part 107 license, and I also do some recreational flying. But, I love taking pictures of towers. But they're just, cinematic pictures. They're nothing of a professional nature in terms of, what can you actually do with a drone? But on today's show, we've got Phil Larsen. Phil is here, and I'll just bring Phil in, and let's let Phil tell you about himself. Phil, welcome into This Week in Radio Tech. Good to see you.
It's good to be here. Thank you so much. Really appreciate the opportunity.
Phil, tell us. Yeah. Tell us about what you do, the company that you work with.
That'd be great. My name is Phil Larsen. Again, as you mentioned, I'm the Vice President of QForce, the Airborne Division of QCommunications out of Kansas City, Missouri. I run the Utah office, which is basically the national office for the Airborne Division, and we run drones all over the country, and we have crews out running around all the time doing different types of scopes of work and working with our friends in the broadcast industry, telecommunication industry, solar, wind, and a few others.
You sound like you guys are into a lot of different technologies, not only broadcast. And I was looking at your resume earlier and saw you had something to do with intercepting communications from maybe from terrorists using drone technology. Give me a little. What got you interested in drones and RF? The intersection of these two really awesome technologies, drone flying and RF, and doing something with that. What got you interested?
So, I had a really unique opportunity when I was working for the Department of Defense, and there was a lot of doors were opened up around, things that we could do, things that we needed to do, things that we wanted to do. And one of the things that opened up for us was the use of drones in regards to, how we can attach certain equipment to it, how long can we get it to fly, what can it do for as far as downlinking back to give us viable, real live actionable data. And one of the things that we did along with the counterterrorism units is we designed a system that allowed us to detect cell phone signals, isolate those down, lock in the SMEs, and be able then to track an individual of question. So that's where I kind of started with that. And having a background in telecommunications and other communications and working around, obviously, the national security sector, we figured out there was a way of doing that and doing it efficiently enough to allow our CTU units to be able to help us out in the world and identify the bad guys, so to speak, and kind of make it a little bit better place.
I really appreciate that kind of work. And glad there are people, smart people like you who have been on that, and I'm sure people continuing on that. But today we're a show about radio and RF, whether it's radio or television. So we're going to be talking to Phil Larsen about what he and his company do in terms of measuring RF coming off of towers. So that's what we're going to be talking about. You've tuned into This Week in Radio Tech. I'm Kirk Harnack, and our show is brought to you in part by Nautel. And I want to tell you about what Nautel is up to. First of all, they have this promotion going on. Nautel, the transmitter company, they make AM and FM transmitters. They also make shortwave transmitters. But here we're talking about a couple of offers from Nautel First of all, on their GV series. So these are big FM transmitters. The GV20, 20 kilowatts, and the GE40, 40 kilowatts. For a limited time, you get a free backup exciter, or a free second exciter, or as their website says, a free second backup exciter. I'm not sure how many exciters you get. That's why you need to talk to your Nautel representative. If you're in the middle part of the U.S., well, you know it's Jeff Welton, and find out who your rep is for anywhere else in the U.S. or anywhere around the world, actually. Go to nautel.com/offers. Nautel.com/offers. The other offer that they're making right now is one that great for broadcasters like me. I have the Nautel VS 2.5 transmitter, and they're offering a $4,000 savings on that transmitter right now. And if you get the HD component for that, that's the Nautel VS HD, you get $6,000 off of that. Now, because of math, you're actually allowed to combine these two offers and get a total of $10,000 off that combination of a Nautel VS 2.5, 2.5 kilowatt FM transmitter, and a VSHD. And actually, yours truly, we're doing that exact thing in American Samoa, so we can transmit on an HD channel there, and we're looking at doing that on our cluster in Mississippi as well. So check that out. Go to nautel.com/offers. The other thing that Nautel is continuing to do is their Transmission Talk Tuesday webinars, not just webinars, but roundtable discussions. If you want to participate, you can. Just join the webinar and hey, let Jeff Welton know that you'd like to make a comment or ask a question, and Jeff will let you write in and talk to the guest or talk to Jeff. They do have 4 such roundtable discussions on Transmission Talk Tuesday in August. So they have them scheduled for August 10th, 17th, 24th, and 31st. And they're at noon Eastern time. If you haven't signed up for these, it's easy to do. Although right now, they haven't set the topics yet, so you can't sign up at the very time of this live transmission of This Week in Radio Tech. But if you just click on nautel.com/webinars and then click on Transmission Talk Tuesday, this is where you can go. They do have archived Transmission Talk Tuesday roundtable discussions available. You can see that right there on the website. Go to the Transmission Talk Tuesdays, click on archived transmissions, archive shows, and you can see a show if you've missed one. A lot of great information there about taking care of your transmitter sites. So thanks a lot, Nautel, for sponsoring This Week in Radio Tech and for letting me make some announcements about that. All right, here we are with Phil Larsen with QForce, part of QCommunications. Phil, I want you to take us through a journey here of measurements. During the next hour, we've got a few videos to show, 3 or 4 videos. And Phil, I took the liberty of grabbing a PDF report that's on your website that shows some measurements, I believe. So if you want to just kind of start us out, tell us about what you guys are doing and why it's important for broadcasters to know about your services and know what they can get out of it.
Absolutely. The best part we love about doing the RF spectrum analysis works is it allows us to do things that historically wasn't really able to be done. A lot of the stuff that we do is in actuality. It is not interpolated. It doesn't get massaged in the processing side. It doesn't get some kind of theory put behind it saying, I think that's what it looks like, or I think that's what it is. There's no question about what it is we do. When we grab that signal, it is what it is. It's exactly where it is. And because our airframes are basically survey grade type of equipment, that we know exactly where that point of time is, wherever we're flying, whatever height, whatever distance. And so we're able then to actually say, this is what your signal is actually doing. And that's the benefit of it. A lot of the historical means that was done previous to the drone operations, or being able to fly at height, or even a helicopter, had some limitations in regards to its positioning capabilities, obviously because it's a helicopter. But the drone doesn't have a lot of that. And the historical way of doing it basically said, I'm going to grab these 40 points. I'm going to be able to then draft out what is we think your signal is because of those 40 points and the way those 40 points are collected. Don't get me wrong. These were really great means and methods at the time, and they allowed really smart engineers to be able to dissect some of that information and make some pretty good decisions. The difference is that the drone, when the drone collects it, we're actually able to then give them the ability to make even better decisions, and not even just better, but immediate as well. So when you put up points off the ground, you're basically collecting those stronger points, and it does give you that pattern of what your antenna is actually doing. But it doesn't give you the refraction. It doesn't give you, if the antenna is too close to the structure, it needs to be stood off. It doesn't give you any interference that might be coming from something else. Where this technology does that, and it allows us to really provide our customers with some wealth of data that they weren't used to getting, for one. Second, and it gives them the ability to make really quick, informed decisions, and or have the assurance that what they purchased is what's actually up there, and it's operating. So if you take those two and you combine it with take that pattern verification, and combine it with the coverage verification, now you're just solidifying the information. It's just maximizes the results, and then it gives you that overall understanding of where that signal is going, how strong it's going there, how high is it reaching, yada, yada, yada. There's a lot of different things around this that allowed the engineers to just really have more information than they've ever had before. And a lot of the compliments that we get is more of the surprise, like, wow, I didn't know I could get that. I didn't know that existed. I didn't know that above 30 feet in the field coverage verification, there was still a lot going on that I didn't know about. And that's where the difference between the drone is. The drone allows us to fly higher, much higher than a 30-foot manned stick. So we average about 90 feet, and that gives us a really good understanding of that signal. And where 30 feet is 30 feet. And I know that's the height of where the FCC calls that the height of the house. And, it kind of gives you a good understanding, but it's really good to understand what's happening above that. So, what's trailing over, right? For engineers to make a really good decision, they need to know both of these things combined.
Yeah, on the one hand, and I've done some FM measurements before with a close to 30-foot pole, and the results can vary widely. You move the antenna a couple of feet, and you could be double or half the amount of signal.
That's right.
And I know that, and then you could also, of course, use a drone up at altitude, up at the antenna's altitude, but nobody lives up there. So it's interesting to get the data. What is the antenna putting out at altitude, at the antenna's altitude? What is the antenna putting out at a, I wouldn't say a compromise height, but at a height where you're free of local obstructions, above a house, above an area, up and down a motorway, and then what's it putting out? What are people receiving on the ground? And if you're armed with all that information at these different altitudes, I guess you can tell a lot more. I mean, obviously, if you're at altitude, at the antenna's altitude, and you notice a big gap in your coverage, well, you're not going to get it on the ground then either, are you?
Right. And so when we fly these pattern verifications, we generally fly. We have a lot of rules and regulations around this, Kirk. So the problem is it's not necessarily a problem, but it's something that we had to solution, and our partnership with our 6 Arms is solutioned. It is basically we can find where that near field and far field is, be able to collect that at height of the antenna. So the benefit of it is, and I can go through a little bit of the process in regards to how we get that median point of your antenna and how we use those median points to ascertain with the structure stability or a level to the structure, if it's planed right. But we use that information out there to grab that strongest signal of that pattern, and then it recreates that pattern. But then we know at that elevation, just because of the down tilt information, we know what that trickling effect should be at radius, right? And so as we do our math and we go out into the coverage and we pick that airframe up, I expect to see it at 20 meters away or 20 kilometers away. I expect to see it at this particular range. That's what we project. And if it's not there, then we ask why, right? So we start thinking about why, and we go a little higher and see where it's finally getting to that range. What interfered, what didn't interfere, so we can kind of give those. Benefit of it is we give that report. That understanding is basically in the field. That's happening on the behalf of our customers, but at the same time we're trying to get it to where we can get a great report, right? We want to understand what's going on with that signal so we can give that information back, so then the engineers can make better informed decisions. And again, it comes down to the general manager as well, right? They want to know their signals getting out there, for their sales and things like that. So we want to make sure we're giving them the best information.
Phil, what occurs to me is that a station owner, an engineer, wants to know what is my actual coverage, and maybe more importantly, what are coverage problems that I could do something about? If I have a coverage problem that's caused by a high-rise building in the way, And I had this happen to me in Memphis, Tennessee, and I did it the old-fashioned way. I had to plot it on topo maps. We had a part of Interstate 240 along the south side of Memphis where this little 6 kilowatt Class A FM station, it was just terrible coverage along a certain part of I-240, an important part of I-240. And the station owner kept asking me, why do we have a problem? Now, it'd be neat to have a drone to do this, although what I did was took topo maps and I drew out, okay, here's the transmitter site, here's I-240 where we have a problem, and then I found out, wait a minute, there's a 13-story hotel that is exactly crossways right in the way of I-240, and the height of the hotel was perfect for blocking the FM signal down that part of I-240, and I marked on the side streets where the signal should come back because it was no longer shadowed by this hotel, and that worked perfectly. Now, there's nothing we could do with that. We couldn't ask the hotel to move, right? And we really, where we were, we couldn't have a taller tower. So it was a problem we absolutely had to live with. And it wasn't bad enough to do an on-channel booster. So from you guys, I want to know about problems that I can fix by rearranging the antenna or getting the tower company, the antenna company out there to figure out, was it mounted incorrectly? Should it have some redirectors on it? What should we do to make this pattern so that we have signal where we want? Am I thinking about that correctly in terms of what you guys
are?
do?
Yeah, exactly. Well, we don't build the topographicals unless the customer asks us for it. It's not part of our basic report. But what we do end up doing is we will when we pull those geographical references, which we call TPs, those are test points that we pull from the in-field coverage. And then we have what we call the CTPs, which is our customer test points. So as if I was speaking with you and you had said, hey, wrong 240, I'm getting nothing, I want to know what's going on. Well, we would have been able to quickly ascertain for you by doing some flights in there. We would have said nothing, hotel above hotel, you got something. So then we would actually say, hey, there's something blocking this signal because of the distance between that antenna and the point that I'm doing this test point or CT point is something's wrong. I should be at X. Remember the math I mentioned a minute ago? We try to figure out what that dB degradation is all the way out to the end. And then we say, okay, between here and here and here, this is where it should be. And so then we give it a report back is that we're not just collecting the information to send it to the engineer and doing nothing with it. We don't believe that that's a good way of going about it. We want to understand your signal as much as you want to understand your signals. And the day is when we see that sign and we say something's wrong, we're on the phone with the engineer saying something's wrong. So we have to get some kind of notification there.
So coming up, Phil, listen, I've selected 4 videos off of your website. We're going to just, we're not going to hear the drone noise. We're just going to narrate over those coming up in a few minutes. I want to see that. Also, you've got some show and tell. Behind you got an amazing drone. Oh, I'm so envious. We're going to take a look at that. That's all coming up on This Week in Radio Tech in a few minutes. Right now, we're going to hear from our friends at Broadcast Bionics. Amazing people to help you make better content for your broadcast. All about Camera One. We'll be right back.
Camera One from Broadcast Bionics. Designed to bring video to your audio content. Visualizing radio and podcasts for social media. Camera One can automatically create, capture and brand professionally switched video for live streaming or upload, making your production shareable. Control and configure using a web browser on any device. Camera One is available as a 4-camera or 8-camera system using the Blackmagic A10 Mini range, including the A10 Mini Extreme. You can use cameras to suit your studio and your budget. You'll need 1 camera for a studio wide shot and usually 1 camera per microphone. A standard multi-channel sound card or IP driver monitors audio from each studio microphone, and we work natively with Axia systems. Ideally, this will be a post-fader feed from each mic, although you can use pre-fade audio or a mic split if that's all you have available. These audio levels are used to intelligently switch the video feed when each contributor is talking. You can also group microphones together into one shot and use the audio from a mixer's aux bus. You can use Camera One's auto switch feature, or disable it and switch using the on-screen buttons or the buttons on the A10. Recordings can automatically start when you tell the system you're on the air. This on-air indication can be linked to your studio's red lights via IP or an Avantec Adam GPIO interface. You can quickly browse all the videos that have been automatically created during your broadcast, download them and post. Camera One is a user-installable system. You'll need a good spec Windows 10 PC, i7 with plenty of storage and 16 gig of RAM. It's better if this machine isn't used for anything else. Remember, you can control the software in a web browser on another device on your network. Camera One, a thrifty way of creating scroll-stopping video from your show or podcast from Broadcast Bionics.
Really cool stuff from Broadcast Bionics. Plenty of other products as well from Broadcast Bionics. Go to bionic.radio. Yes, that's a real website, bionic.radio. You can also go to bionics.co.uk. So there's a couple ways to get there. But I like bionic.radio. Easy to remember. Check them out if you would. Thanks a lot, Broadcast Bionics, from This Week in Radio Tech. All right, Kirk Harnack on This Week in Radio Tech, our 555th episode, 555. Our guest is Phil Larsen. He is the Vice President of over at QForce, a division of QCommunications. They do an amazing amount of technical work, not only in the broadcast industry. Phil, we're going to salt and pepper a couple of videos. I got 3 of them all together here lined up. These are from your website, and they're in no particular order because I think you'd be comfortable narrating any of them. Phil, if you don't mind, we've got the first one queued up. It's called Lofty HRP Smooth. Is it okay if we show that one and have you tell us what's going on? So Suncast, our producer, is going to show that, and Phil, your mic will be up, and you can just tell us what we're looking at here. Suncast, go ahead. There we go. Ooh, look at that.
Okay, so this is a really great shot. This is actually a camera that's been mounted to the airframe to be able to collect the visual acuity of what we're collecting. And one of the things that's really notable in this is that you notice the airframe is keeping that tower in the center of the frame. This is very important. And again, it speaks to the technology behind the airframe and what we're running is that we're using that technology to ensure that the antenna is proportionately correct always to the structure and that antenna that we're measuring. And that's the beauty of this. It's a lot of fun. This is actually just a straight video climb here. This is one of our tower inspection video. This allows us to, we run this in a 4K high definition video. We're allowed to collect that information straight up for climbers. This particular one is actually on a cell tower, and right now we're actually just doing some quick testing on regards to RF mapping, and that allows us to generate what that signal is doing at that location, and then we can back it off and start doing the dB designation on the telecommunications side of the house.
Hey, and Suncast, maybe a few minutes from now, I'd like to have, I realize those videos are pretty short. Suncast, I think in a few minutes, I'd like to re-look at the brand and extension video and the King's Forest video and have Phil give him an opportunity to tell us a little bit more about what we're looking at there. So maybe in a few minutes, kind of tee those up again. Phil, you've got a drone behind you there, and I don't know what's convenient for you to show us or to get up and show us. Feel welcome to get up and walk about if you want to, but maybe you could tell us about what we're looking at behind you. That I've got drone envy. I've got a DJI Mavic Pro, and I love this little thing. It makes beautiful cinematic shots. I've made a bunch of movies, put some music behind them, and I'm just, my eyes and ears are happy. But I got no RF data whatsoever, of course.
Well, you probably flew in some, that's for sure.
Oh my goodness, yes. Oh my goodness, yeah.
Yeah.
What you got there?
Well, so the aircraft behind me is manufacturer's proprietary to us, and it is actually a BFD made out of Passaquin, New Jersey. That's a team that we work very closely with. They're a very good integrator for us. This airframe is designed specifically to do nothing but the RF measurements. It'll do a whole host of other things, but it's a heavy lift airframe. It flies for up to an hour, depending on its payload. But it really allows us to pick up the equipment and then be able to fly in a very steady, controlled environment. This has a wind gust rating of up to 40 miles an hour. We've tested it at that and actually tested a little higher, and we know that we can still hold our positioning pretty good. We don't recommend flying at 40 miles an hour gust ratings, though. So it is completely carbon fiber. A lot of the parts on it are carbon fiber. A lot of them are plastic, so that we reduce the amount of refraction. Our antenna system actually hangs below this particular airframe and drops down below it, so we're reducing any interference onto the antenna so that we're giving our customers exact results without trying to dissect what was coming off of the airframe. And right now we have literally none, pretty much. Nothing that's consequential anyway for us to do. It is a 6-foot bird, tip to tip. When you open the tips up, she's a pretty lengthy airframe. But again, it's a heavy lift, and it flies within a space of accuracy no greater than this. So, 4 or 5 inches. So when we're actually collecting your signal, when we do that signal, we use this airframe to do all the broadcast work. It'll fly up, grabbing an elevation pattern, which is cutting through your signal, and then we'll fly over and come down through it again. Sometimes we do that multiple times. And what we do there is we're actually grabbing where that signal's sitting in point in time and space. So it could be, if the antenna's racked, we'll see that. We'll see an up tilt and a down tilt on each side. And if it's sitting pretty good, we'll see a comparable down tilt on each side. So we use the median of that to get us the most accurate information as far as collecting as where we on a horizontal pattern. And this particular airframe will do that pattern. High powers, we can be done in 26 minutes with that particular flight. But it gives us all of that data so beautifully and accurately that it's hard to beat that when you get the real information like that. But again, it runs a dual RTK system in conjunction with its own internal telemetry system. It has a triple redundancy backup system. So in the event that I lose link, it switches to another one. And if I lose that link, which is completely unlikely, then it has another built-in feature to bring it home safely. That's in mind of the structure and everything else as well. So it's a pretty smart airframe in regards to that. And then what it actually does for us is really, really state of the art. No one has this, and this is an important feature that I want to stress to you and your audience is that just because a couple of guys have a drone and a pickup truck and they would go out and to take some measurements or take some video of your broadcast structures, you shouldn't want that to happen, because again, a lot of time and energy and effort has gone into making sure that airframe can fly around those signals without any interference issues, without flyaways, and with the exceptional reduction in risk on the airframe to be a potential falling hazard. So with that being said, that's why this airframe is designed the way it is. We spent the time and energy to do that, and it flies around those signals without any issue whatsoever. And basically, we need it to, right? That's what we do. Yeah. So it's one of the best.
Tell me about what kind of antennas are you using to capture your samples with? And I guess you've got to understand their characteristics at the frequencies that you're measuring. And what polarizations typically are you capturing?
Well, so you're kind of tipping right on our proprietary line there. So our antennas are custom built for us. They're specifically designed for the U.S., and we have others that are specifically designed for other parts of the world to meet those channels and those wattages and things like that, polarizations. So our antennas are designed to work in the U.S. They range from X to Y, and that's all they do. And then we have others that are for AM, FM that are ranged in the same configuration. So we really don't divulge a lot of that. They like say that's kind of our trade secret, but it is the reason why we're so accurate, is because again, when I use the correct antenna and it's designed and attenuated correctly and blocked correctly, then we actually are able to collect just that signal without any interference to it. I'm not giving you a report that has any fluff or any padding in it from anything else. And so that's kind of in our proprietary house.
Yeah, and I understand there are things that you do that you guys have worked on design. It's your intellectual property. Can you tell me anything about the challenge of, in doing spectral analysis, which I've done some of that? It's often a challenge to measure the desired signal versus the undesired signal, or signals I don't care about, especially if the desired signal is small and the undesired signal is huge. So maybe you're measuring a low power TV that's way up on a tower, and it's on a tower with some big full power TVs and full power FMs. What are some, without giving away intellectual property, are there some things that you can do to help guarantee that you are actually measuring the desired signal and ignoring the undesired signals?
Yeah, absolutely. The box that sits on there, again, with our partnership with the 6 Arms, the box that's there it's specifically that, Kurt. I dial in on that signal and it filters everything else out. I don't get it unless I want it. Now, if I want it and I want to collect it separately, I can do that too without interfering the primary. So I can actually do multiple collections at the same time if they're within the same range of space that I'm working in. If not, it's got to be a different flight, right? Obviously for the elevation of the antennas. But if I wanted to put it on the specific one, and that's the only one, I can filter out everything else. But if I wanted to say, all right, what is that high power doing to that low power? How much am I getting of that high power when I'm flying at this low power elevation? I can kind of figure that out. Most of the time, we don't share that information unless it's been that's the request, and the two want to talk about that and what, how they're working together on the tower as a collaborated effort. Then we would share that. But we kind of want to know too, if we're part of making the recommendation and giving a good report to our customers, we want to know what's going on, and that way we can actually say, hey, you are getting a little weaker interference here, so you might want to just have a chat with your friend a little higher than you.
Well, the interference brings up a question. When you have high power devices, you can certainly, if you have, for example, a rusty connection somewhere or dissimilar metals, you can get a passive intermod going on. This used to happen all the time when I lived in Memphis, Tennessee. We had a 300 kilowatt FM station in Memphis, WMC FM. I think they were a couple hundred watts horizontal and 100 kilowatts vertical, but 300 kilowatts altogether. And there were oftentimes interference issues on FAA frequencies, on aviation channels. It turned out that every single problem they had was the FAA's problem. It wasn't. It was their fault. But they'd hear WMC coming in, on radio channels where they shouldn't be. So of course the finger would be pointed at WMC. But it was all dissimilar metals in their own system that were rusty. So that brings to the question: what can you guys do? Normally, I think of you as measuring patterns, looking for where the signal should be, and it isn't. What can you guys do to help track down sources of interference?
Absolutely. That's a great question. And we can do that in multiple ways. First of all, let's just say the visual side, right? So just flying the structure for one. Let's just put the airframe up. Let's look at the structure. Let's look at everything going on with the structure in regards to what is rusted, what is corroded, what is swinging, what got left up there during a decom that shouldn't be up there, that could be causing something going on, all of that. So the first is the visual side of the house, and we perform a lot of visuals out there, and we love doing the visuals for a couple of reasons. One is to identify any particular refractive things that might be happening or anything that might be hazardous. But then again, we like giving those videos to the owners so that the tower crews that are coming after us can actually have something to look at, so they can look at where they're going to anchor to, where they're going to rig something to, get an idea before they climb. Again, safety is one of my biggest components that I do all the time, and I'm always worried about the tower climbers climbing a structure. And if we can give them a video ahead of time to identify that, then that's great, right? They can actually make better informed decisions too, just from that video. So there's a couple things we can do on that. The first is obviously the inspection of the video inspection, which is nothing more than a visual. And then we can do the thermal as well. That helps us identify where things might be going a little crazy inside the lines. And the thermal provides you, it's like a line sweep, but in a sense, to me, I think it's better than a line sweep, because a line sweep is more of a line side inside of things, whereas a thermal shows me where I might have a potential burnout, where I might have a nitrogen leak, where the connectors might not be together, or I might have an internal block on one of the rifts. So it really does kind of add more to the story to make, if you're a detective, if you will, you use the visual, you use the thermal, you use the pattern analysis. And then, obviously if there's a problem with the line set and it's got a burnout or something's happening in it with a line, the signal's being, jammed up in there, or if we're getting the interference from something else, we see that in the pattern verification. We see math doesn't add up, right? So 100 kilowatts going out this direction should be X, Y, and Z. If it doesn't, then something's wrong. Is it being blocked, or is it not being transmitted correctly? Are you reaching your contour lines that you paid for? That's the other thing we look at. Is so we take all of that into consideration. You add all those together, and you basically get what we call our routine maintenance program, where we look at everything and provide you 100% detail of what's happening on the structure. And we take it a step further, and a lot of times we throw the photogrammetry involved, and we'll give you a 2D rendering, and then we'll highlight the key points that you need to know.
You used a word just then. I'm not sure I heard it. Photogrammetry? Was that it?
Photogrammetry, yes, sir.
What does that mean? That's a big word.
That's a big word, yeah. And believe me, I had to study it too. It's basically what it is. It's nothing more than stitching of a series of pictures together. and basically create you a 3D model of the structure. The benefit of that is a lot of people can do photogrammetry, your DJIs can do photogrammetry, things like that, but it's all about the back end processing of that data. Everything's about the processing of what the customer sees, and what they need to see and what they want to see. Might always be the same, but what we try to do is give them enough information in this 3D model that they can turn, flip, rotate, and move around. But when we highlight the sections of where their aperture is, we can make it different colors. We can show the anchor, the distance between them, on the standoffs and things like that. We give them a lot of really good information. But when you start collaging all of this together, you take the video, you take the photogrammetry side of it, you marry those together, and basically out of those hundreds and hundreds and hundreds of pictures, I can actually isolate one picture, drive into that one picture, and then go down to the nut and bolt and actually measure threads on a nut. So I know if it's torqued, whether it's pressed together, the connection joints is good. So there's a lot of good things that combined. When you use the drone in an effective way, then you can actually really, really get a ton of information you never even gleaned you thought you couldn't get without a climber. But then climbers have limitations too, right? They climb up and they look through. All right, they look through that leg. They don't climb every leg. When you do use a drone sees every leg. I can zoom in on any part of that leg. I can look at any part of that leg. I can isolate the leg. And in our repository system, you can actually see, if I want to show you just between 50 and 60 feet, I can just show you that much. If I want to show you 100 to 150 feet, we can just see that much. Then make all those reports around that particular space. So there's a lot of good things that can be done in use of a drone. And this technology is really evolving and coming out into the world with the use case. And it should be used, in my book. Less climbs, right? Need less climbs.
Make sure I understand. You can take a series of photographs from different angles of a tower, and then you can put that into a program, and it will model that in 3D to let you smoothly move that around and see it from different angles.
Yes, sir.
And you've got enough resolution where you can zoom in and even see threads on a bolt. Yeah.
Yep. Yeah. And then scale it, right? So we can do construction drawings as well. So the end of the day is the best part is, like, a lot of people don't, like, there's towers out there that have been out there for years, right? You know that. They've been out there for hundreds of years almost. Not hundreds, but you know what I mean? A long time. Point is that they don't have any paperwork behind them. They don't have any construction drawings or as-builts or things that are left behind. We're able to fly the entire structure. We're the only ones in the industry at this moment that can fly above the 600 and grab all of that data and still be scalable to roll that completely into CAD files that can be scaled and used as construction drawings to add, subtract, or do whatever.
Okay, so this is a way to recreate drawings of as-built of your tower in case it's an old tower.
We're basically giving you an as-built. Yeah.
Wow.
And that's what it is now, right? So that's what's on there now. That's the apertures. We identify those. We identify the cabling, the weight. So now engineers they can say, well, there's a lot of load on this thing. Is it still correct? Are we still within our wind ratings? Are we still doing the things we need to be doing to make sure this thing's safe and staying in the air? And for me, the benefit of what I like to know is that our work, the ability of the drones in doing this, Kirk, is it allows it to stays that we don't have any failures, and we don't have people on them that are falling with them. We don't have anything that are falling over and we lose signals and things like that. I'm a big fan on those things.
Folks, we're talking to Phil Larsen. Phil is vice president over at QForce, part of QCommunications. Obviously, they do all kinds of measurement and analysis on signals coming off of broadcast towers, and they measure and analyze a lot of other things as well. The QCommunications website's pretty amazing, all the technologies that they're doing and the combination of unmanned aerial vehicles, drones, and as it applies to lots of different things. Hey, it's This Week in Radio Tech, our 555th episode. I'm Kirk Harnack, not in the Telos Alliance studio today, still wearing the shirt. I really appreciate Telos for giving me a little time off to talk to people like Phil Larsen. Our show is brought to you in part by Broadcasters General Store, where you can find all the products from Broadcast Tools. This is Don Wingett's company, Broadcast Tools, and they have an amazing array of things that just make broadcasting easier and better. I've used Broadcast Tools equipment for literally decades now, and the stuff just does what it's supposed to do. The ProMix 4 is a great example of this. The ProMix 4 little audio console that you can get. And you know what? Isn't it a little funny that we'd be talking about a mono audio console? But this console is not for your main on-air broadcast. No, this is for taking out to sporting events. Now that COVID is getting over, maybe we're getting our sporting events back. Well, this is an easy console for your sports guys to take out in the field, get up in the the press box and do their broadcasts from. It's also a great console to use for home broadcasting, for podcasting, for voiceover work. The 4-channel mixer with USB is the Pro Mix 4. So check that out. Now you can get this from Broadcast General Store. But let's tell you some of the features in the Pro Mix 4. It actually is a full-featured audio mixing console for broadcast studios, especially for voiceovers, while being great for remote broadcasts and for podcasting. It features 3 mic and or line inputs, either way, as well as a dedicated line input. You can also switch between the balanced line input and the internal USB connection to your laptop. So if you've got audio coming from your laptop, you can mix that right in and send it right back to your laptop or computer. So maybe you're doing a show on Zoom, or maybe you're whatever you're producing, whatever you're sending somewhere else, whatever app you want to use on your computer, you can send your audio from the console to it digitally through that USB connection. You also get a program limiter, a balanced and unbalanced mix bus, and a mix minus output. So you can use it with your codec. You can use it with, let's say the Angry Audio Bluetooth audio gadget, for example, works great with that. It has 3 independent headphone amplifiers with IFB and program pan controls, along with a comprehensive studio monitoring system. You also get that mix minus output, as I mentioned, the built-in USB codec, an easy LED audio meter for your VU meter. Even your jocks can hopefully tell when the meter turns red and their level's too hot. You get full duplex talkback capability. And the headphone jacks, they're professional 1/4-inch stereo headphone outputs with independent volume on them. And it also works with their AHR1 Plus headphone system that Broadcast Tools offers. You need to check this box out. This is it's got the tally light control also to turn on your tally light. And that's something that those little consoles, we know names like Behringer and Mackie, those consoles don't have that. They don't have mix minus. Yeah, you can create a mix minus, but your jock's likely to mess that up. This, you're not going to mess it up. It's going to work for you every single time. The Broadcast Tools Pro Mix 4. Check it out from Broadcaster's General Store. You go to bgs.cc. They're really set up to take your phone calls at Broadcaster General Store. They love talking to you on the phone. You get great advice. It actually has been the highlight of my day. Hey, I'm going to call Jessica at Broadcaster's General Store at 352-622-7700. 352-622-7700 for Broadcaster's General Store. Thanks, BGS, and Don Wingett at Broadcast Tools for sponsoring This Week in Radio Tech. I'm Kirk Harnack. Our guest is Phil Larsen. He is with QForce. Phil, are you one of the pilots yourself on these drones?
Kirk, I used to be. When we started this division, that required me to be out there, and I enjoy being out there. I'm a pilot. I've got thousands of hours of time in the air, and I mean, we had to design it, right? We had to make it work. We had to test it. We had to do all those things, and then obviously, I enjoy flying it. And there's I'll have to give you the opportunity, Kirk. I'll have to find you, and we'll get this bird in your hands and let you really understand what it means to fly a big airframe. But it's fun to fly them. They're a lot of fun to fly, and I don't fly anymore. I have way too many people that are doing that for me now. But I still get out now and then. I'll pick this guy up and scare the neighbors.
My DJI drone has a beginner mode, and I like that. It also has a tripod mode, which it moves about 1 inch per second in tripod mode. And I hand it over to my 10-year-old son. Here, put the tripod here. Michael, fly it. And it's I'm flying it. Yeah, that's great. It won't go far.
Yeah, you're having a good time. Yeah,
I'd love to fly a big.
My 14 and 16-year-old fly for us, and they fly this one. They don't fly for QForce, but they're all part of this family, and this whole family flies. So they had to graduate out of those DJIs like that, and then grab up into this one, and we let them fly this one now and then, and it's again, it's a pucker factor. This is a big airframe, and she'll get you going.
So in a obviously drones, we've been talking about DJI drones, and they're very much, most of their lines are intended for the consumer market. They do make some drones intended for law enforcement, for things like bridge inspections, things like that. So they're in different business categories. But one thing that I've always appreciated about even my little Mavic Pro is that it's very stable in the air. It's GPS. It has some kind of camera system looking at the ground. Plus, it has what's the word? Accelerometers in it. So it uses all these things to be stable. A drone like yours, and I know you have a partnership with Six Arms, but a drone like yours, does it have that kind of stability all built into it, or is it a bit more of a manual experience?
No, Kurt. It's actually, you just basically everything you just said. This
Mhm.
has plus the dual RTK and basically on steroids. So it has everything on there.
You've said RTK a couple times. Can you tell me what that means?
Yeah.
Real
So that's
time
real time kinetic.
kinetic.
Um,
There you go. Okay.
Yep, real time kinetic. And basically, we run a dual RTK system. That means when we fly, we're locking into 20 to 22 different satellites. And that's
Mhm.
between the Russian, France, European, and US.
Wow.
That locks us into our position. I mean, like I say, when you fly your DJI and you say return to home, it's going to land within 3 feet of where it took off from. That's kind of an
Yeah.
average, right? Where this one's going to land within 3 inches. So that's
Wow.
the difference.
Mm.
So the granularity in why we use this is that other airframes will do the scope of work like we're doing. But again, it's when we say I want to stay at this particular point, let's say 150 meters in the air, I don't want it to be 151 or 149. I want it to be
Yeah.
150. So we
So
stay, and that's why I say we fly within 4 inches of that actual measurement is where we want it to be, and that's what the benefit is of what we do.
when you go to do let's say a fairly standard, as standard as it can be, set of measurements on a signal, do you measure some number of points, or do you measure continuously as you go around
Continue.
or go to different places?
Yeah, continuously. So in that
Okay.
report that you have that you pulled off of our website, you'll actually be able to see that in that report because one of the things that we show in that report is we show there's a gray line, and that gray line is a little bit bigger, a little bit fuzzier, but that is all of the thousands of points that are being collected during that orbit. And then we take the system, it actually takes and highlights the strong points that make up that collage of those gray points, and then we
Mhm.
overlap the projected analysis from the antenna manufacturer over the top of that to see how close those signals are, or that pattern is, and that way we can actually tell if it's aimed correctly. That's another big
Mhm.
thing, right? If it's aimed, we've actually had customers that have been 11 to 12 degrees off, so they're aiming in the wrong way. And we've been able to give them that because our equipment is survey grade, and that way we know where we're at in time. I know where that
Yeah.
dirt pile is. I know where the antenna is. So at the end of the day, is when I say that your pattern is cocked like this, we're not the ones that are wrong, and we've had to actually prove that in a couple of cases. But
Let's see if Suncast can bring up that PDF page that I mentioned to him earlier. Let's see. I want to go to the page before this. I think Suncast, the one that's got there you go. The patterns, the kind of scalloped patterns around there. That one. Yeah. Is this what you're talking about, Phil, or is it something else? I just found
actually, I
this.
think it's one lower than that. You want to go down a little bit?
Oh, okay. I thought that one.
Okay, so
No.
right here, let's stop here, and I'll tell you about this.
Okay.
This is
Okay.
your elevation slice. This is important to understand. You see those red marks that are right there in that both of those graphs.
Yeah.
So that is exactly where the airframe went through, and as you can see as it climbs, because you know how to read a chart, you flip it over, of course. But as the airplane was flying up there, it found that strongest point and you can see out of those lobes below it, and it found that strongest point, and then we identify that strongest point as your beam tilt is 1.24 on this side, and I'm sorry, I can't see the other side, but whatever that median is between that, we would actually fly at that. So we were flying in that red point, that very, very finite red point to collect your signal. So that's an elevation slice. That's important to know because if the beam tilts are parallel to each other or within reason, then we know your antenna is fairly level. And that's a good thing because you want to know that from an engineering standpoint. Then if you go down or back up, I think it's up on your side there if you go up.
Suncast, yeah, scroll up there.
There's some, okay, so this particular site that we're looking at now, it's had 4 of those elevation slices, which is great because that it really allows us to know the northeast, west, and south kind of coordinates. We call them faces in our work, but it allows us to see exactly if it's a 360 degree on the antenna that's going out, then we know exactly what its plane is. And so you can see 1.49 on this one. And I don't know what the other one is, I can't see it, but point is that we then find that median inside of there. So we'll probably fly this one at 1.32.
So I take it that every flight is recorded with GPS positioning. So if you need to come back after the tower crew had done their work, or a year later, or 5 years later, could you get that drone into precisely the same positions it was before?
Same thing. We save all the flights. Every time we go out to a site, we'll save that flight. We'll mark where our truck was, a GPS coordinate of where the truck was and the base station in comparison to where the drone took off. So we have to triangulate all those things together between the airframe, the launch point, the base station, and then the structure. And so we get all of those triangulated together. So yeah, every year, in fact, in our routine maintenance program, that we do that. As we go back, we put the vehicle and the airframe back in the exact same locations, and we fly the exact same mission. The benefit of that is to see what's degraded over time, what's changed. So if like a tornado or a hurricane came in and you wanted to go out just to make sure everything's still in the same place that you left it, that's the ability to do that. Because of the granularity that this particular types of airframes can do, that's something that people can just have a peace of mind with, knowing that they're actually still secure, everything's still there, everything's still working efficiently, and getting the best results.
Phil, do you use the same airframe to do RF measurements as you use to do any photo visuals? Is there any difference in the setup with those two functions?
Oh, yeah. So it depends on the structure height. Structure height. So this particular airframe does do the photos as well. It runs a T3 gimbal. It's a pretty good sized gimbal with an A7 Sony mirrorless camera on it with a 60 millimeter, 35 or 25 millimeters camera. Whatever it is that we're running on there for that particular inspection, this one does the bigger structures. So 2,500 feet and lower kind of a thing, 3,000, doesn't matter. This one does all of that. But then we actually do use some of the M300s and the M200, 210s, dual RTK systems. Because again, the pictures have to be RTK'd as well. For the geographical reference of the structure against the picture and things on the ground and relationships. So we run RTK on every one of them. So we do run some of the DJIs, but we strip them down to basically be in the airframe and just a little bit of our ARM integrated software in those. So that we're able to get that information. But we do run Phantom 4s for some of the cellular work in the telecommunication industry. And then we do run some of the M210s and the 300s.
Do you have any pet names for these? Like, I've always thought the Phantom series was called the Flying Coffee Table. Maybe you've got some other pet names.
Well, Kirk, our pilots are crazy. My chief pilot and trainer is named Alec, and he's a wealth of knowledge, just a brilliant individual. But he has names for them. So we have 2 M210s that are Mary Kate and Ashley. So he actually names all of our airframes. I don't know the name of this one off the top of my head, but he knows the names of them. But this one's number 4 in the lineup, and he knows the name for it. So every one of the airframes have them. And then one of the other things, we have those Maverick Air Pros 2s that every one of our crew members has. We buy them for them as part of their backpack arrangements. And in an event of like natural disasters or, the icing, like in Texas, for example, our teams were out there in Texas flying all the broadcast structures for our friends out there. We maybe we don't know them. We did know them. We don't know them. Don't matter. We went out and flew all of them for a visual, just a visual to see where the icing was, to see what was going on, see if anything's wedged or done anything. And we did that for free. But we did them all with the Maverick Air Pros, because I could do a quick zip on those and be able to hit multiple at one time, and then be able to come back and we process the data and the footage and give it to our friends in the broadcast industry.
You mentioned that the drone behind you is capable of staying up for near an hour. Does the pilot get tired after an hour? When my drone's out of battery at 20, 21, 22 minutes, I'm ready for it to come back anyway.
Yeah, they do. It's the best part is it does fly autonomous. So I'll explain that. We fly autonomous only at the top of the mission. And what that means is that we do not pick up an airframe in autonomous, and we do not land it in autonomous. I'm not a big fan of those. I don't believe them. It's to me, I think that's when you have the most risk, is when an airplane is taken off the ground. Everyone should agree with that. And landing an airframe, right? That's aviation basic 101 stuff. But landing in autonomous mode, I think the bird has to make decisions that might not be the best decision for it at that time. So we'll actually pick up the airframe. Our pilots will pick it up. They'll do a quick pilot check, which is making it turn, move side to side, yaw, and pitch, and then call out vocally that pilot has command of the airframe, and then engage the mission. From there, they'll fly out to the waypoint that they've set up to be their first waypoint before the actual waypoints of the mission, and then they'll release the airframe into auto. That is conveyed back by the VO who's watching the heads-up display and all the other different instrumentation regarding the airframe. And the pilot's job is to pilot, right? We run things just a little bit differently here because at the end of the day is I want the pilot with his eyes on the bird at all times. In case something happens, something needs to be done. He has quick stick control. And the VO runs all of the heads-up displays, watch all the EKF warnings, and make sure nothing's going wrong with the airframe and the data's coming in. We can see that as it does. So at the end of the day is they do get tired, because at the end of the day, we're literally on site for a good day doing these flights, depending on the type of antenna, whether it's horizontal and vertical, and if it's high power or low power, just it dictates the time on site. But we're there for a long time, and getting all this information collected, but it's generally no longer than a day, maybe 6 to 8 hours. We have been on site though for almost 15 hours, and we're trying to troubleshoot. And that's a long day for a pilot. So if you think you were tired after 21 minutes, these guys are wore out.
Hey, I wish we had more time. I've got a couple more quick questions we'll try to squeeze in here, and then we'll have a commercial break, and then our tip of the week that Phil's going to leave us with. Phil, I was wondering about, most tall towers are nowhere near an airport, but what kind of air traffic coordination might you need to do in your line of work?
That's a good question. So I'll quickly summarize that. The 107 allows us to fly against structure pretty good. In relation to its height, 400 feet above and radius sides of it. That usually gives us a pretty good radius to fly in and against the structure itself. And there's a lot of parts to a structure, so that's really defines where that space is. But in certain areas, the tower actually might climb into different airspace. That's not a G airspace. It might fly into something a little differently. So we usually petition for that. We run it by the FAA either through the LANS program, or we make specific waiver requests to do that type of work. And we work so well with the FAA in so many different ways that these things aren't very hard for us to get done in a matter of minutes and get approval for. And we're the only ones that actually can fly around high towers like the Freedom Tower and the Willis Tower.
Oh, wow.
Because of our relationships.
Okay. Yeah, that's amazing. So my last question is, how have you found that you best deal with either the public or maybe uninformed or law enforcement officers who don't know what you're doing? Maybe they've had a complaint. Hey, there's somebody looking at my girlfriend on the swimming pool.
Yeah.
What have you found to be a good way to deal with that? You're a professional. I'm sure you're in the right, but you've got to let people know that no, everything's okay. Right. Everything's all right.
Absolutely. The best thing is to be professional and courteous and upfront, right? Because we're flying drones around, everyone suspects that, Kirk. Everyone thinks I got a video camera on it. Everyone thinks that I'm looking over in the pool, the backyard, and that's not even remotely close. We don't fly any video cameras on our equipment that can do anything other than like what that one video you saw, which is no good to anybody unless the bird's flying, 10 feet around you. So we don't do any of that, and we've been approached by the police. We've been approached by the municipalities. We've been approached by just the common, walker up, the civilians. And our guys are all trained in this, and we've even had the hostiles, right? The hostile people come up to us, and they're all trained to do X, Y, and Z in regards to always be polite, bring the airframe down, talk to them, show them, educate them, give them a chance to look at everything, show them the data that we're doing. There's no cameras and things like that. And most of the time, people are they have that misconception in their minds about what these drones are doing, and that's usually it, right? It's usually spying on people. Now, in my former career, yeah, that would have been true, but in this particular career, not a chance. We don't do that. We don't have any relation to that, and it's good. It's just about being very professional, and most of our team is 100% right on the board with that, and they'll take the hour to talk to him to calm him down. Again, we're not on site out in the CVs for more than 15 minutes to do these elevation flights, so we're kind of in and out. But if it takes us 45 minutes to talk to somebody to give them an education, we're in. We love talking about drones. It's the easy part.
Okay, I have one more quick question. Is there a sophisticated way that your drones can avoid the hazard of flying into a guy wire, or is it visual?
Yeah, it's a visual thing. It's a pilot training thing, Kirk. Because here's the thing: is you can have all the obstacle avoidance and everything else you want on an airframe, and that's a good thing to have, especially depending on what scope of work you're doing. But guy wires are not really visible. They're not really seen by some of that technology. So we have very specific plans on how we enter an air compound, how we leave that compound, where we go with that, what elevation we go with that at. The pre-study of our work is well in advance of us getting to the site. We don't show up and decide to do X, Y, and Z. We know what we're doing once we show up there. That's because we've looked at that structure, we've evaluated that structure, we've put azimuth to the structure in regards to guy wires, how many guy wires, what's the elevation of the guy wires, what's the distance of the guy wires that reach out from the structure. We know all of the information around that structure well in advance before we get there, and that's conveyed to our pilots. And then they know their flight plan that's been researched prior to them arriving, and they just validate that that's still a good plan there, or they make slight adjustments to accentuate it or make it better.
My favorite plan for avoiding guy wires myself is to fly around self-supporting towers. That works for me.
Yeah,
no guy wires.
I had to do I did a demo for a Crown Castle years back, and I had to fly through guy wires doing orbits. And I have to set the autonomous flight to do orbits and then lift up between the guy wires and then do another one, lift up between the guy wires, and it was a good flight, but we made it work and we proved the art of possible, we can get that granular level on a guy wire structure, but it's not recommended, Kirk. I'm a pretty good pilot, but even that one kind of like, this is a matter of just chance whether or not I'm going to lose this airframe today or not. So, but we didn't lose it and we got the data. So we can say we do it, but that's about as far as it goes.
I got to fly one time around a tower that was built in a former Soviet state, and it's no longer part of the no longer Soviet. But anyway, I didn't know if I was allowed to be there or not, so I was hiding in the bushes, flying around, and turned out there were a whole bunch of UHF transmitters in that tower, and I kept losing control. Luckily, it was a tall tower, but it was unguyed because it was huge self-supporting tower built during Soviet times. Anyway, it turned out everything I was doing was completely legal, no problem at all. I got a beautiful video out of it. Just lost control about 6 times while it was in the RF field. Well, and there was an ultralight flying around the same place. I was being very careful. Let's get away from this guy.
Right. Man. Well, then you kind of have to. That's a manned aircraft, right?
Yes. I had to be away from him.
I was fighting for the tower space with the FAA in regards to allowing us to fly drones around it. And one guy asked me, he says, well, what are you going to do when you see a manned aircraft flying at you? And I said, I'm going to deviate from a manned aircraft every time, no matter what. We're going to go up, we're going to go down, we're going to go sideways. We're going to get out of the way no matter what it is, what means we have to do to get out of it. And then I'm going to turn on my video camera. And the guy looked at me and he says, why would you turn on your video camera? And I says, because the NTSB is going to want to know what was going through that plane at the last minute of its crash. If it's coming into a broadcast tower, he's got bigger problems than my drone. And the guy looked at me and he kind of smiled, and we're friends to this day, but he was kind of like, yeah, you're a jerk. I'm like, but I'm true, but I'm right. Planes avoid those things like the plague, and they should. Right. And having someone fly around, that's just nuts.
You know how legal wording is so often, and on your tower authorization as a broadcaster, your beacon lights have to be visible from any normal angle of approach. And as a pilot, I've got to wonder, well, from what angle would I normally approach a tower?
What's your normal and my normal?
I wouldn't. I would not have
Right.
normally approached the tower. Hey, Phil, we're going to be right back with you for a tip of the week at the very end of our show. I'm Kirk Harnack. It's This Week in Radio Tech, episode 555. And I want to tell you about this thing right here. You see this? This, I'll put it right in front of my forehead here. This is the Angry Audio Disconnector. Now, I know in broadcast engineering, we work so hard to connect things together. This is a 1/4-inch tip ring sleeve connector for a headphone. But guess what? Your guest is wearing headphones, and they're not very good at what they do. And they get up when they're wearing the headphones, and bam! Look at that. It comes apart. This is kind of like a MagSafe connector for headphones. What a great idea from Mike Dosh at Angry Audio. This is called the Headphone Disconnector. And if you go to angryaudio.com and just look under products, scroll all the way to the bottom. And hey, Suncast, if you want to do this, you can show that. All the way down to the bottom of the products listing is the Headphone Disconnector. And this is what you want because bam! So you plug this in the series with your headphones, right? You plug this into your audio console, wherever your headphone jack is, and you plug your headphones now into this female jack here, and the talent can get up and walk away and see, there you go. The Headphone Disconnector. Go to angryaudio.com, and there it is. What a great idea. And it's available in the 1/4-inch tip ring sleeve. It's also available in the 1/8 inch or the 3.5 millimeter tip ring sleeve. And guess what? The connectors are the same on either one. So this also lets you transition from a 1/4-inch, maybe a headphone jack into a 3.5 millimeter or vice versa. You can get back and forth that way. Just buy a couple of these and wow, what a great idea. The Headphone Disconnector from Angry Audio. Angry Audio also has all of your Studio Hub supplies. So you can do your Studio Hub adapters here. I forgot to unfurl this. Let's just untangle that. There you go. So you go from your professional XLR connectors over to your RJ45s, and then just get whatever length of Cat5 cable you need to get over to your X node or your Blade or whatever thing you're plugging into. Check that out from angryaudio.com. Thanks a lot, Angry Audio, for sponsoring This Week in Radio Tech. Our show is also brought to you by our friends at Max Connect. We'll be right back.
I'm Gary Morrill, Midwest Regional Director of Engineering for Alpha Media. When I first spoke with Josh Bone about Max Connect, he told me they'd work great for remote transmitter sites where connectivity was a challenge. And he's absolutely right. We even have sites where we're using this as a backup to our STL using Max Connect's dual carrier option, and it works perfectly. We also have times where we need to be able to get out to a venue where it's kind of challenging because everybody and his brother is trying to stream video at the same time, like at a big sporting event. And you know what? Our data gets through every time because it's prioritized packet data. It works for us. It'll work for you. Max Connect. Check it out.
I did. Here it is. This one is from Pepwave. This is a 4G LTE modem, and that's not the important part. The important part are the SIM cards that go inside, and you get those from Max Connect Wireless. Check out their website. You'll find all of it. You can get you a trial of this. You get you a fixed IP address, and you get guaranteed packet data that you're not subject to, the other 50,000 fans in the stadium. Your data gets through from Max Connect Wireless. Thanks so much, Josh Bone. You've done a great service to our industry for inventing Max Connect Wireless. All right, it's Kirk Harnack. We have one more quick segment, and we just got a couple of minutes. So, Phil, maybe you've got a tip of the week you can leave our listeners with and make them feel like they've been educated.
Yeah, great. Thank you, Kirk. My tip of the week is this: drones are they're here to stay. They have the capabilities of doing the work that you want them to do to get the information you want them to do. They're going to give you better, faster results. They're going to give you some great data that you can use to make really good informed decisions. And they're here to do that job. Let them do the job, but make sure that you're doing it with the right people. That's my tip. Yes, not every drone should be flying around a broadcast structure. Not every person who has a drone should be flying around a broadcast structure. It's important to understand that just because they have a drone doesn't mean that it's capable of doing the work. The last thing you want to do is not be just projecting the news, but be on the news because you actually had an incident with a drone on your site. So that's my tip.
That is a good point. And it has taken companies like yours, like the folks at Six Arms and others, years to come up with calibrated information, calibrated reception capability, so that the readings are accurate and they're repeatable as well. Sorry about the camera moving around there. No, I'm not having an earthquake. Phil, if folks want to get in touch with your company, what's a website?
So it's just qcom.tv. QCOM.tv is a great way of finding us. My information's there, and you can just reach me via email or phone, and love to talk with you.
We will put that on the show notes for this episode. Phil, we got to go. It's time. Suncast turns into a pumpkin in 45 seconds. So we're going to let
Sounds good. Thank you so much.
Thank you for joining us, Phil. It's been great to talk with you. I appreciate your time.
My time, it's always yours, Kirk. Thank you so much. Appreciate yours, and thanks for having us on today.
All right. Phil Larsen, the Vice President at QForce, part of QCommunications, and we'll put the links in the show notes. Hey, coming up, we got a great month ahead, August, for some good guests. Jim Graham is going to join us with some hilarious stories of broadcasting in the past and close to the future, and transmitter side pictures and the near disaster that he's been through. That's coming up. And plus, Tim Coaches is going to be with us during the month of August, and a few other new people, new guests on This Week in Radio Tech. So we'll see you next time. Be sure you hit like and subscribe on the YouTube channel. That'd be wonderful. Tell your friends about us. And most importantly, visit our sponsors, because, hey, they pay to bring this to you, and I really appreciate that. We'll see you next week. Oh, thanks to Suncast. Thanks also to Andrew Zarian, the founder of the GFQ Network, home of lots of great podcasts. We'll see you next week on This Week in Radio Tech.